Welcome back, everyone. Before we get started, I do want to point out that I have already started my instance. It's the Data Science 3.0 image with the 8 virtual CPUs and 32 gigabytes, okay? That's the MLT32 extra large. Keep in mind that this does cost about $0.5 per hour, but we're still in the EDA notebook, okay? So if that's too much for you, feel free to follow along. By the way, if you follow this along with me, it shouldn't cost you more than, like $1 or $2, depending on how long it takes you to get through this section. But this is not a very long section, okay? So this is actually going to be the final part of the exploratory data analysis. We're going to be working on creating some visualizations, okay? We're going to be creating a bar chart, which is going to show us the distribution of categories. And we're also going to be creating a pie chart that is going to show the proportion of each category. Okay, so let's get started. I'm going to import Seaborn as SNS and import matplotlib.pyplot as PLT. Okay, these are very common visualization libraries in Python. So I'm going to say plt.figure, and the fixed size is going to be equal to, it's going to be 10 by 6. And this is going to be for the bar chart. You can just write bar chart. What's very important is whenever you shut down a Sagemaker instance, it's not going to keep your data in memory, okay? Which means you're going to have to go back and rerun these cells, okay? Because you're going to have access to DF work. And, if you just logged in and you just spin up this instance, it's not going to know what DF work is, okay? So you have to rerun all of the previous cells. You can even test that your getRandomTitle_by_category function is working as well. For me, it's working. So now let's get back to over here. And now I'm going to say sns.countPlot. And for that, we have to tell what the data is, and the data is going to be equal to the DF work that I told you that we need to have access to. And now this is very important that the X value, what we're looking at, so over here we're telling which column it should look at. And it's very important that whatever project you're working on, you spell this exactly as the column name you want, okay? So it's going to be the category column, and the order is going to be equal to df_work. This is just some boilerplate code that basically tells, we want it in all of the values, and, the order should be as it is in the category column, okay? So now we want the value counts, and we want the index of that. So this will tell us basically how many counts we have in each category, okay? So how many counts we have in the entertainment, business, science, and health category. So that's what we're working on over here. Now I'm going to say plt.title. We can add a title, and I'm going to say that the title is going to be distribution of categories. Nice. And I'm going to say plt.xticks. And we're going to say that the rotation is going to be equal to 45. And that's basically, you'll see once we create the graph, what it does, it basically rotates the labels on the x-axis a little bit. And now if we do plt.show, we should get the distribution of categories. So, by the way, this is the x-ticks, okay? The rotation of 45 degrees. Slightly slanted, okay? So over here, we have the count on the y-axis and the category on the x-axis. So as you can see, we have health, science, business, and entertainment. It's fairly balanced. I've worked with a lot more unbalanced data set before. We can see that we have approximately 50,000 in the health. We have, about 110,000 in science, about 120,000 in the business, and we have about 150,000 in the entertainment. Now, some people might say that this looks a little bit unbalanced, and that could be true. However, in our case, we have over 40,000 in the health category. So, if we had like 1,000 total, and we only had like 40 that belongs to the health category, that would be an issue. But with the 40 few thousand examples, we're going to be fine with the health. Now, in real life or in real nature, if you have this issue, what you do is you go out and get more data, or, you have some techniques such as the SMOTI technique, which is the synthetic minority oversampling technique, which, for example, if we come over here and I do SMOTI, here it is, SMOTI for imbalance classification with Python, you can read about this. It basically allows you to create additional data for the imbalanced class. You have other ways. You have KNNs that you can use that creates additional examples, or nowadays you can use LLMs to create additional examples. So, you have many different ways as to how you can generate or get more data. But in our case, in our scenario, this is fine. So this 42,000 is going to be enough for us. It's not imbalanced. I would say it's actually fairly well-balanced data set. So now let's continue and create our pie chart. Okay, so I'm going to say that the category counts is going to be equal to df_work. And we look at the category and we say value counts, value_counts. This basically, what this does is, it checks how many unique categories there are. Okay, so we have 1, 2, 3, 4, entertainment, business, science, and health. So that's what we're doing over here. Now we can say plt.figure, and I'm going to say fixed size is going to be equal to 8 by 8. And I'm going to say plt.pie. This is going to be our pie chart. And I'm just going to say category counts. That's the first parameter that it accepts, how many unique categories we have. Then we have the labels, and the labels is going to be equal to category_counts dot index. So that's the index is either going to be entertainment, business, science, or health. And then we have the auto PCT, and we're going to set this. I'm going to tell you what this is in just a second. I'm going to set this to %1.1f%. So the auto PCT is a parameter used to format the labels of the pie chart slices to display the percentage value. In this case, the 1.1f specifies that the percentage should be displayed with 1 decimal place. Okay. And now we also have the start angle. Start angle is going to be equal to 140. And that's just, it's similar to these business ticks. Okay. It's just some additional making it nicer. Then I'm going to do plt.title. We add a title to it, and I'm going to say portion of each category. Nice. And then we have plt.show. And let's see what the error is. Fixed size. Okay, so I misspelled that over here. Sorry, everyone. Fig size. So here it is. As you can see, we have the proportion of each category. So we have 36.1% in entertainment, 27.5% in business, 25.6% in science, and the health is just short of 11%. Now, I know that we could use, much nicer visualizations such as Plotly. If you have heard of it, you can make really beautiful visualizations. However, let me tell you a secret. When you're in machine learning and you're working on real projects where you have 400,000 data points, you can basically say goodbye to Plotly and these beautiful visualizations because they require a lot of additional compute and memory. So that's why in projects, you will often see these ugly graphs. So, this is not an ugly graph, but it's just, it does what it needs to do, but it's not super beautiful like a Plotly graph. So, and if you want to, get into visualizations, you have different teams in your data team. You have, for example, an analytics engineer, and they use Tableau, Power BI, or AWS QuickSight to load in millions of data points, and then they can create nice visualizations. But just keep that in mind when you're working with lots of data. For example, our CSV is over 100 megabytes large. That's not going to fit into a single Plotly graph. And if you don't know what Plotly is, you can come over here and you can go to Plotly graphs. They make beautiful graphs. Okay, so if you can come over here, if you look at Plotly graphs, as you can see, they're interactive. So you can click on it, you see, you can zoom in on it. They're beautiful and they're really nice. And, they're a very good way to impress your boss, But most of the times you will either have to spin up a very powerful EC2 server to be able to load that in. So, just stick with this, or if you, really have to, then talk with the analytics engineers or the data engineers, and they will help you set it up with, as I mentioned before, Power BI, Tableau, Amazon QuickSight. So don't be surprised that most of the times when you're working in big teams, you'll see these kinds of graphs, which are nice, but, not super fancy. Okay, so that was just a practical tip. I will see you in the next video. And this concludes our exploratory data analysis.